So we are doing the combination of cell. Have we done the series grouping? Is this part done? Series grouping?
Yes, sir. Parallel grouping is there.
Parallel, we have to start or parallel is done?
No, we have to start.
All right. So the purpose of parallel grouping is if we have multiple cells, tomorrow is connected across another cell, and now this is the parallel grouping of two cell. We'll start with the two cell, and now this is called the terminal of the combination. A and B are the terminal of the combination, and that terminal, through that terminal you may connect some load resistance. Now what is load resistance? If you remember, load resistance is referring to any appliances at your home. Okay, so let's say you're trying to drive this appliance using the parallel combination, and because we are dealing with the real cell, and we know that for real cell we do have something called the internal resistance. So the energy that they are capable of generating, that energy cannot be delivered to the load completely, because there will be some internal consumption as well, right? In case of ideal cell, the energy developed is directly given to the load. So there is no internal consumption of energy. So definitely the A and B, which we call terminal, will not give you the full energy, and how much it will give, we have to derive. So first of all, we'll remove the load again. We'll keep the cell only. Keep the cell itself. And again, you have to remember that we have to find the voltage that the terminal will generate, because through that terminal we are going to connect some load. So A and B are terminal. So the question is, what is the terminal potential difference? What is the potential between A and B? Now, if you look at this part of the circuit, this itself is a complete circuit. Why? Because it forms a closed loop. Do you all realize this? That this forms a closed loop. Therefore, this itself is a closed, or you can say complete circuit. It's clear to all of you that this is representing a complete circuit.
Yes.
And because this is a closed loop, can we expect some current? Can we expect some current? Yes or no? Yes, we can expect
Yes,
some
sir.
current. Now, to make it more, you can say, user friendly, let's convert this real cell into combination of ideal cell and a series resistance, right? You can redraw something like this, if you remember the last. So can we redraw like this? Tell me guys. Yes.
Yes.
Now I have no idea which one is bigger, whether it's E1 or E2. I have no idea which one is bigger. So what I will do is I will make some assumption. So you are free to choose the assumption. So let's take E2 is more than E1. Okay, so let E2 is more than E1. And why this assumption is required? Just to make the current direction okay in a finite way. So either it is clockwise or anti-clockwise, but it is the E1 E2 the relationship which will determine the final flow of current. So if I'm assuming E2 is more than E1, then how the current will be clockwise or anti-clockwise?
Clockwise.
Clockwise. So let's call this current as I. Why? We have only one loop, so there must be only one current. So in a single loop, the current will be only one value, I. So now tell me which one is charging and which one is discharging. Looking at the circuit, can you tell me or suggest me that which cell is charging and which cell is discharging?
E1 is charging.
Very good. So what you can add next? You can add the KVL, Kirchhoff's voltage law. So do you all remember the KVL? Kirchhoff's voltage law. So I hope you know how to work in a circuit. If you don't know, let me know. I'll recap the way to move in a circuit. So let me give you this recap. For any circuit, if you face a resistor and if you move along the current, if this is the direction of motion in a circuit, direction of motion in a circuit, that's too much verbose. If this is the direction of current in a circuit, motion, sorry, direction of motion in a circuit, and if the arrow is representing the direction of current, along the flow, potential will drop or rise. Along the flow, potential will drop because we go from high to low potential, right? Current goes from high to low potential. So if you move right, you will find a drop of IR value between this end and this end, A and B. So the B is IR below the A. Is this clear?
Yes.
Yes, sir.
Just for recap, if we have a capacitor with known polarity, let's say plus and minus, and capacitance C. And if this is the direction of motion in a circuit, then if you go from A to C, you're going from the positive plate to the negative plate, then again there is a fall of potential. And the value of fall will be equivalent of minus Q by C, where Q is the charge on the plate and C is the capacitance of this capacitor. Now, when it comes to the cell, the cell. A cell, okay, we are considering the real cell, sorry, ideal cell of EMF E. The cell will have plus and minus, which is by default, and it doesn't depend on the current direction. So cell will have its own potential high and low. And therefore, if you go from A to B, again, if this is what you are trying to move, If this is the direction of motion in circuit, so you are again going from the high potential of the cell to the low potential. There is again drop of value E. E itself is a value. For every question, what I'll do is I'll draw a same diagram in here. If this is your direction of motion in a circuit, it is plus IR. If this is your same, plus Q by C, and if this is your same, then plus C. As of now, we are going to face R, C, and E in this chapter. So I'll confine our discussion to these three elements. In the chapter of electromagnetic induction, you will come across inductor, and I will discuss there itself the sign convention and the way of writing potential difference. Now, when I say walking in a circuit, so a circuit is like a path, and walking means you trace the path. And while you trace the path, you face some element. You face either capacitor, resistor, or battery, or cell. And then there is a connecting wires. So connecting wires will not offer any drop or rise. You can say that connecting wires are like a path without any, or you can say uniform potential path. So in the connecting wires, we don't write the potential drop or rise. Only when we face some element, circuit element like R, C, or E, we write the plus or minus, the drop or rise of potential. What we do? Just stop. Okay. All right. Am I audible?
Yes, sir.
So now can you move in a circuit? Just so as per the KVL, if you start from some point in a circuit and if you come back to the same point, the net rise in potential or the drop will be zero because you are back to the same point. And a single point of a circuit will have only unique value of potential. So when you make a round trip journey, you actually come back to the same potential and therefore the rise and fall will be zero. So the way to start is you can name it, just name it, let's say O. And then walk the path, come back to the same point, and you're free to walk. You want to walk like this or like this, it's up to you. So let me walk clockwise like this. So starting at O, we have no idea about potential. So let's call it VO. Okay, then walk right. When you walk right, you will face the cell first. So drop or rise. If you cross like this, drop a value, even.
Yeah.
Okay, let's assume the current as I in the same sense. Then across R1, what will happen? Potential will drop or rise.
Drop.
Then across R2
Drop again.
and across E2.
It will rise by 8.
After all these things, you're coming back to the same point. This gets cancelled. So either you write this way, and then you know that this will get cancelled. So what you're getting is minus E1 minus I R1 plus R2. Oh, sorry. Plus E2 equals to 0. I turns out to be how much? E2 minus E1 upon R1 plus R2. This is your I. And once you get the I by moving the KVL, by writing the KVL, the next step is finding the terminal potential of the parallel combination. So now I want the potential of A and B. So in how many ways I can go from A to B? Tell me, guys. In how many ways we can go from A to B? There are two ways. There are two paths actually. Think in terms of paths. How many paths you have to go from A to B?
2 parts.
Either the top path or the bottom path, right?
Yeah.
Now again,
Yes.
you're free to choose because these are parallel circuit. So they will give you same potential difference no matter whether you go top or bottom. So I'm going from the top. Okay. How to write it? Let's learn this part. This is very, very important part. You all should be very careful in learning this part. How we write it? So we say VA because I have no idea what is the potential of A. Then I trace the path, go to the upper path. What I will face first? A cell. And when I cross it, the drop or rise will be how much?
Minus even. Drop.
Minus. And then I have to cross R1 also. Drop or rise?
Draw minus ION.
And I'm back to the point B because see, my journey is only from A to B. I'm looking for VA minus BB and I got the answer. This we could have written directly because we know this is the charging case, and for charging case, the terminal potential is always E plus IR. How many of you remember this part? Everyone. So this is called the terminal potential difference of the parallel circuit. And now the next job is substitute the value of I because we know I. So I'll name it E equivalent because this is the equivalent potential difference that I can get. And if I rearrange, after taking LCM, E1 R1 plus E1 R2 plus E2 R1 minus E1 R1 all upon the E equivalent, we are getting how much? You can see this will get cancelled. So it's very nice answer, E1 R2 plus E2 R1 upon. Now this answer is very, very important if you are learning cell and if you are learning the combination of cell in parallel. This formula you must remember. But there is a simple way of remembering this answer. So what you can write is E equal to E1 R2 E2 R1 the better way of writing is divide the numerator and the denominator by R1 R2. It will become E1 by R1 E2 by R2 1 by R1 1 by R2. Now if you look at carefully, this 1 by R1 and 1 by R2 is representing the equivalent resistance for parallel combination, if you remember the formula. So for parallel grouping of resistance, what we write? 1 by R equivalent equation 1 by R1 plus 1 by R2 plus 1 by R3 and so on. So by dimension, E by R represents current. By dimension, 1 by R represents okay, this is the inverse of ohm. So it will become current into R equivalent. So this we can write as it is like dimension. You can think of anyway. You can leave this here only. And the equivalent internal resistance of the combination of cell we can directly write as. And now if you want, you can write as 1 by R equivalent is so every parallel combination can be written as, if we have parallel combination of cell, we can reduce this combination as a single cell and a single resistance, and we call it E equivalent and R equivalent. And the formula of E equivalent you can write as summation of EI by RI. You can take any number of parallel cells, not only 2, upon 1 by R. So the takeaway is, if every cell is in parallel with same polarity, so if every one is the plus is left and minus right or vice versa, if all polarities are same, you simply add the ratio E1 by R1, you just add for every value, you will get the equivalent. If the polarities are opposite, we have to change the sign. So we have to make it minus. Okay. You can choose right as positive, left is negative, or left as positive, right is negative. If the final answer is negative, it means your assumption was opposite of the actual. If the final answer is positive, it means the way you assume was correct way. of assumption. So no need to worry with the assumption. You can choose whatever assumption you are happy with. Now, what is the benefit of solving? I mean, reducing the circuit like this? This is called basically Millman's search. Yeah. So for any cell in parallel, you can reduce into a single cell with single E and single R, and that you can apply to other part of circuit to solve the question. The benefit is enormous. The moment you see a complex circuit, and although it is not a cell, if you have E and R in combination, you can think as a cell, a real cell. So let's see if I give you a question like this, which we have solved previously also, now in a different way. So we'll start with some simple example. Now, no one will tell you that this is a cell and you have to assume it. No. Question is find the current through R. What they ask? What is I? That's it. There is only one part. You can see clearly the question is demanding current through one specific branch. So other branch is not required here. But if you look carefully, that each branch can be thought as a. So if you look at the parallel values of ER, 2ER, these are like cell, the real cell in parallel. Do you realize this?
Yes.
So what you can do? There are many ways in which you can solve, but one of the ways you can think of reducing these two into equivalent by definition. So I'll keep R as such because I want the current through R. So this is the desirable branch. I cannot reduce this branch, but the other two is not desirable. I mean, we are not going to do some calculation there. So we can reduce it by single E and single R. So what is the equivalent, guys? Tell me. By definition, E by R plus
2E by.
and 1 by R plus 1 by R.
Yeah.
Right?
Yes.
This is 3 by
2.
See, this is so simple. And now finding the current through this branch is very simple because this is the single loop, and we know current in a loop is the net EMF of the loop upon net resistance of the loop. See, we are done. So the answer is 3 by 2 R plus how much? What is the R equivalent, by the way? So for two resistance in parallel of value R and R, the equivalent is R by 2.
Yeah.
And we're done. See, we got the current through the specific branch without affecting other part of circuit because we are not interested in the calculation in the rest of the part. So we can reduce it. Okay. So the answer is 3 by 2R plus R. Now, can we take all three into consideration? The answer is yes, you can take because a resistance without cell can be thought as a cell of zero potential. So the other perspective is I can think as a cell of 0 volt. And now you can see these are three cells in parallel. So I can find the terminal potential easily. So what is the equivalent, guys? What is the equivalent? Directly you can write. Apply the same formula and tell me what is equivalent for the entire combination. So can we write this as 0 by R?
Yeah.
E by R?
3 by R plus 2E by.
1 by R plus 1 by R plus 1 by R.
Yes.
This is again 3 by R upon, and this is 1 by R plus 2 by R.
2 by.
We have to take LCM, right? Now this is the potential across A and B. This is A and B. And because we know the potential across A and B, we know every path will carry some current because we know the potential difference. We can find the current easily. So A is at a high potential and B, so current will flow like this. And therefore, the IR must be equal to how much? The answer which we got, right? The drop across this one will be same as this value. Yes or no? In parallel combination, all potential difference is same. So IR is representing the net answer which we got. So you can see the same. So it is up to you the way you want to solve. What are the other ways of solving?
Sir, can we do by KCL?
Yes. But that will be even expensive affair here. Let's see.
It will be very low.
Have I discussed the mesh analysis in the capita? Now, what is a mesh? So if you remember the mesh sieve, the filter, the filter which you use to filter the tea or coffee or whatever. So what is mesh sieve? The net. You make a net of wires, and every hole which you see is called mesh. Now, if you think circuit as some sort of mesh sieve, how many holes do you see? There are two holes. The rule says that every hole will have its own current. This called I1 is the whole current, the first, current in the first hole, and I2 is the current in the second hole. Let's assume this way. Okay. So this is the first step. You assume I1, I2 as a current, and you are assuming the complete circulating current in every hole. Now, in this two hole, there is a common branch. Do you see the common branch? This is the common branch, isn't it?
Yeah.
So this branch is a part of the first hole. This branch is a part of second hole. So this branch will have two current, I1 and I2. And you can see the I1 and I2 are in the opposite sense. So I1 is left and I2 is right. Do you realize this?
Yes, sir.
So how we attempt question based on the mesh analysis. So for every loop we write KVL. Write KVL for each mesh. Now this technique is for the worst case scenario. I mean, generally for JEE advanced question, we don't need mesh analysis. We can solve every question with the remaining ideas which we have learned so far. But if you really get stuck and you're not able to understand how to proceed, in that bad situation, I would say that apply the mesh analysis. Now in engineering, what happens? In engineering, we have we have real life values of, we have real circuits. In real circuits, the values are very bad. And also the way of solving in the engineering is not conventional way of solving here. So we use calculator to solve the matrices. Okay. So we have a calculator which can solve the matrices also. So there the mesh is the best way because it is eventually going to be solved by the machine, not by you. So no matter how bad the values are, machine will have a simple way of doing it. It will calculate and give you the answer. You have to just put the answer in the answer key. For JEE preparation, we are not allowed to use the calculator. We have to do the calculation manually. So MES becomes a tedious job here, and that's why I say it is not recommended for JEE preparation. For your BTech first semester, I'm giving this idea. This is called there's the branch called elements of electrical engineering, and in that subject, okay, you will learn the mesh analysis, and you will have the calculator to be allowed to be used in the examination as well. So what we do is we create the linear equation of number of variable equivalent of the number of mesh. Right now, how many mesh we have? We have only two mesh, right? There are two holes.
Yeah.
So luckily, the number of linear question will be just two. But if the number of loop, the mesh, not loop, if the number of mesh becomes more than 3, 4, 5, 6, 7, it is impossible to solve manually. Okay, then what we do? We write the equation, we put in the calculator, and the calculator is capable of doing the calculation. So we have a calculator which can apply the matrix calculation of any number of arrays. So m by n array can be solved by a calculator. So that is a different story altogether. As of now, you have to do the calculation manually, and therefore we'll restrict the discussion to two loop mesh. Okay, just two, not loop, two mesh circuit. So the mesh is the smallest possible path, closed path, in which there is no subpath, and loop is called any general path. So here, if I ask you how many loops we have, the answer is we have one loop, we have another loop, we have this loop also. So technically we have three closed paths, but if I ask you how many mesh we have, we only look for the independent loop, the loop in which we don't have any sub loop. The mesh, by definition, it is a loop without any sub loop. In case of mesh, we don't have sub loop. In case of loop, we may have some sub loop. So here, the two holes are like independent holes, and inside that hole, you will not find any another loop. Actually, that's called mesh. So mesh means independent loop. Okay. Now, how we write it? The method is simple. Write KVL for each mesh. So let's do it for mesh 1. The way of writing is very simple. You imagine there is only one loop existing, ignore the other loop at all, and write the answer. So if you do so, what will happen? Okay, let me start from here and let's come back to this point. I'm moving this way. So tell me guys what I will write. Ignoring the other loop. What I write?
Sir, minus I1 R
Very good.
minus I1 small r plus E.
Now we have to stop here. This is not complete. Why? Because there is a common branch, and that branch is also having current I2. But I2 will have the opposite direction, right?
Yes.
So what we do is we add I2R as an additional drop or rise. So I2 will create a rise for the given mesh 1. So I2 is coming this way, no? Opposite direction. So what we do? First we write for I1. Once we are done, we check for the common branch, and if the common branch is having current, we add the potential rise because they will move in the opposite sense. So this is I2. Understood? Clear this part? How we are writing this part?
Yes, sir.
And then
Sir,
what we
so
do?
we are adding to balance it.
Yeah, balance it. Because I2 is going opposite direction. If you look at the I2 is going this way, and you are moving to the left.
Yeah.
So there is
Yes,
a rise
sir.
of potential. The I2 will create rise. If everyone else will create the drop, I2 will create the rise. Is this clear? And now this we have to cut to 0 because we are making a loop complete. So we are going back to the same point. So this is 0. Done. Now there is no need to solve. What you can do is rearrange. So you can write I1 R plus R plus I2 R is minus. If you want to make it better, and you will call the equation 1. And you can see there are two variables I1, I2, and we have one equation. We need one more equation. So I'll go to the mesh 2. Now I want you guys to tell me the answer, how to write. So tell me how to think, how to write this second mesh, ignoring the first loop completely. Well, right, and then add the value if there is a common branch. Okay, so go ahead, tell me.
Plus 2E.
Just a moment. So you're beginning from where? From bottom?
Yeah.
From here?
Yeah.
Okay, let's go. Yeah.
Okay, so firstly it will be minus I2R
Okay, great.
plus 2E.
Great.
Then it will be minus E
Very good.
plus minus E minus I2R.
Yeah. Now we have to add the I1 part.
Yeah.
Okay, are you getting this part? Why
Yeah.
we are adding? So that is from the other loop, moving in the opposite direction, so it will add up, and this is it. And this will give you the another equation only. So I can add here is I1R minus 2 I2R plus E equals to 0. So I can write in terms of equation, I can add I1R minus 2R I2 minus. Now what we look here is pure linear equation. The equation in two variable. So two equation, two variable, we know we can solve mathematically, but there is no requirement. Again, you can do it, but as I said, this is not a recommended method in a JEE preparation. Why? This is only for the worst case scenario. If you are not getting any answer in a question, then MES will definitely give you the answer, no matter how difficult the question is. So you're not supposed to think anything. Like you're not supposed to know Millman's theorem. You're not supposed to know charging, discharging, cave. Nothing is required. This is like a blind method of getting the answer, a very blind method, a very hardcore mathematical way of solving the question. So now, if I give you, okay, can you solve these two questions? Probably yes, you can solve. This is not very difficult. And once you solve, you will get I1, I2, and I think I1 is the answer, right? Because R1 is carrying I1 only. No? So if I remove I2, I'll get the answer directly, right? Let me show you just for your clarity. So I can use the equation 1, I1 R plus R minus I2 I can replace by I1 R plus E by 2R. Yes. I can replace. Yeah. This gets cancelled. So we are getting I1 comma R plus R minus
R by 2.
R by 2 and minus E by 2 is E, right?
Yeah.
I1 into R plus R by 2 is 3E by 2. So I1 is 3E by 2R plus R. And this was the answer, right? You can see the answer is matching, right?
Yeah.
Now, definitely the mesh analysis is the worst method which I can recommend. But in a question, when you can see the values are really nice values, 2, 3, 4, something like this, then solving the linear question is even easier. So you can go ahead with mesh also. Choice is yours. I'm not forcing that you must learn this part. But if you can remember, it is helpful to you in the BTech first semester. Probably the first semester you can enjoy because you know everything about first semester. So I wanted to introduce this method through some question only. You can see every question can be solved in multiple ways. Okay, someone was asking that can we solve in KCL? The answer is yes, we can solve. Let me show you the method 4. In circuit, there are so many methods that only through practice you will realize that which one is the best and fastest method. So technically, no one can teach you these all methods that what is the trick to apply which one. But you will get some insight when you solve a large number of questions. You will get the insight. Okay, this kind of question, this trick will work better. So only the exposure can give you the or help you the solving it fast. So let me give you the method 4. So we have seen Millman method, the theorem directly you can apply the formula. And I'm keeping the same example so that you can correlate things. Now, there's a trick. If you want to apply KCL, you need to know the potential of every terminal. Okay. So what I can do is I can choose this as 0 for some weird reason I'm choosing, and this I will call V. Why I'm doing this? Because once I do this, I'm at ease of assigning the potential of every point of the resistor. R, 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 V. Now this end is, you can see this is directly 0. So this is 0 volt. This is 0, but I want this potential. I want the potential of the resistance, the end of the resistance, this point. So I have to move from here to here. If you move from here to here, there is a drop, right? Of what value? Minus. Do you realize this?
Yeah.
And similarly, what is the potential of this point? It's -2.
-2.
So we are done with all potential. We know the formula of junction potential in KCL formula. So junction is same. The formula is same. It is E by R, same value. Right? So what you write? N potential upon resistance, E1 by R1, E2 by R2, E3 by R3 upon 1 by R, 1 by R, 1 by R. That's it. So we got the junction potential directly. So we got the answer V equals to how much? Why it is negative? You can understand this is negative because I assume V on the right side. So V turns out to be R by R. Yeah. So -3 ER by. Okay. Now, because this is 0 and this is V, I can find the current here. I equals to how much? V is negative, so I will go from high to low. So I equals to how much, guys? Ohm's law. I minus low upon R. I is minus V by R. And if you do so, you will get the answer as so. If you can understand this, it's really good. You can play with the idea of KCL, KVL, mesh, Millman's theorem. And rather, I would say you can make a chart of all the methods and put on a wallpaper so that you can recall yourself that, okay, we have so many methods. We have the current divider rule, we have the voltage divider rule, we have the Millman's theorem, we have KVL, we have KCL, we have mesh analysis. And then a question which will face in the JEE examination will be combination of any one of these. Like this should strike in the examination that which one is the best way to approach. But if you know everything, then there is a guarantee you will be able to solve for sure. So in current and electricity chapter of JEE advanced question, I can guarantee that every question, no matter how hard the JEE is going to prepare, you can solve every question with full confidence. Because nothing can go beyond these methods. Okay, so you're learning half of the engineering and half of the JEE advanced. So the purpose of going beyond the JEE is so that you can capture the question for sure in the JEE advanced examination. Okay. And now approach is something which you can develop on your own. Is this clear?
Yes, sir.
So we have done the inverse symmetry question using KCL already. Have we done KCL question?
Yeah, we did investment.
That's true. Okay, so we have seen so many methods. I think in circuit theory, this is more than sufficient. Now we can move to the next concept that's called combination of identical cells and maximum energy transfer. Here. Okay. So when you go to Pani Puri wala, the way he serves every customer is very unique. So the one who is expert technically measures the time taken by each person to eat pani puri and then release the taste for some time. And he put a large number of customers in a queue. So he will keep on serving one after the other. Now, one thing is clear that if he will serve too many customers at one time, then no one will be satisfied because we cannot wait for long time. The entire, you can say, the taste of this pani puri will go away if the waiting time is too much. So of course you want a pause because you are chewing it, digesting it, and enjoying it, and then you wait for your turn. And then the moment you are ready for the next turn, the pani puri is in front of you. So one thing is clear that too many customers will spoil the experience of every customer. And too less is also very bad because if it is too less, then before you complete it, you will get the another one, which is again irritating. Okay, so there is something a balance. A certain number of customers can be served in the best possible way. In a similar fashion, if I have too many cell given to me, if I create a configuration of cell, if I create a like combination of cell, and I have to serve the customer, which is called the load resistance. So a too large load or the too less load is always bad because a combination can serve the best a particular load actually, and that is called the maximum power, maximum energy, maximum not energy, maximum power. Like that. Maximum power transfer theorem, this MPTT. So what kind of load, if attached to the given combination of cell, will draw the maximum power possible? Okay. We know the answer was E square by 4, if you remember the discussion. But the same thing we'll see in a different perspective. So, and we are going to use the identical cell. So each cell which I'm going to use will have the EMF and internal resistance R. And again, we are talking in terms of real cell. This theorem, this idea is only for real cell. We don't apply for the ideal cell. Because ideal cell will always transfer maximum. So there is no meaning of it. The real is important. So we'll start with the series grouping again. So let's say we have n number of cells. How many? N number of cells. And then you connect the load. The load is the appliance which you want to drive using the cell. So what is given to you, this configuration is fixed. You are not going to change the configuration. Okay. So we have a fixed configuration. Now what we are trying to achieve here, for a given configuration, how to maximize the power received by the load. Okay. So every cell is E and all are in series combination. What is the effective value of E equivalent? So if all will have the same polarity, then all driving force will add up. So what is the E equivalent, guys, here? The equivalent E will be how much? Tell me.
M times E by R.
No, only E equivalent. What is E equivalent? It's only NE, no? NE.
NE only. Yeah.
Yeah.
N times. NE. Okay. What is the equivalent resistance of the combination only? Every resistor is in series. What is the R equivalent of series combination? Come on, guys. What is the R equivalent of series combination? See, you can replace
N
the cell
times R.
and
N times
N
R.
times R. That's it. Very good. And now this combination is going to serve this load. We're going to serve the load. I can reduce into a single value NE and NR. And because it's a single loop, so finding the load resistance, load current is very simple. So what is the IL, guys? IL is how much? The net driving force of circuit is N.
NE by NR.
No, it is RL plus NR.
Oh yeah.
The net resistance will add up. No? These two are also in series, right?
Yeah.
Okay. Now, the next question is, how much power is received by the load? Power received by load. And the answer is I square RL, which is NE upon RL plus NR whole square RL. Now look at this formula for some time and let's try to analyze the mathematical beauty of it. If I make the load really small, tending to 0, what will happen? The power will be how much? Almost 0. If RL is 0, the answer is 0, yes or no?
Yeah.
Think mathematically, think RL as some variable X and PL as something Y. So Y equals to Fx is a formula. In the Y equals to Fx formula, if X tends to 0, what is the Y? Think of limit and continuity. It is 0 only.
Yeah. Tending to.
Zero.
Now, why we are going to create a circuit with no consumption of power? We know that we have so many cells, so we can have a sufficient energy to be consumed. So a load with almost 0 resistance will not do the justice to the circuit made. So I will not connect such a resistance because it will consume nothing. So most of the energy that the cell will develop will be consumed by the internal resistance of the cell itself, which is not a good idea. Okay. Now, if I make RL tends to infinity, what will happen? If I make
Power
RL
will
tends
also go.
to, power will again become
Yeah, infinite.
no.
Oh. Yeah. 0.
Zero.
Because the RL in the denominator is square, right?
RL square.
Yeah.
Yeah.
So that is going to give you the 0 answer, isn't it? Understood.
Yes.
So the two scenario of 0 and 0 is not good. So we need to think about what RL is the best choice to receive or deliver maximum power. Okay. So if you know mathematics, you can do it easily. So to maximize the function, what you do, you differentiate, right? So if you go by calculus method, so for PL max, because PL is a function of RL, I'm see, we have to choose RL. It's like we have to choose the number of customers which can be served in the best possible way. Okay. So the Pani Puri wala will choose the number of customers. See, Pani Puri wala is fixed. It will not change. So you have to think of Very well. Okay, so are you differentiating this? So for dPL by dRL must be 0. Can you differentiate and tell me RL, how much are you getting RL? Anyone? Got the answer? Hello guys. Anyone differentiating this question? Or shall I differentiate?
Yes, sir. One sir. Too much time you have taken. Now let me tell the answer. If you do this, you get RL equals to NR. Sir, so after equating to 0, we will get.
Yeah. You have to differentiate and equal to 0, you get this answer.
Yeah.
I'll check.
Anyone getting this answer? So when you guys will learn the differentiation, I don't know. Okay, so the alternative is
Yes, sir, I got.
very good. Now this a plus b whole square we can write as a minus b whole square plus 4ab, right? So now we know that the function will be maximum when the denominator is minimum, right? For PL max, the denominator must be minimum. What is the lowest value of denominator? You can write, okay, you can write like this, just n square, and if you divide, so what is the lowest value of denominator? Because square of any number is positive, the lowest value is possible when this term is 0,
0.
isn't it? So for PL max, that term will be 0, and that is only possible when RL equals to
N.
NR. Understood? Yes or no?
Yes, sir.
Yes, sir.
This is the way of getting an answer. So RL question R. And now this is actually called the maximum power transfer theorem. Maximum transfer theorem. So let me put into words. According to this theorem, the power through load will be maximum if the load resistance is equals to the total internal resistance of the combination of cells. That's simple. So this is now like a rule. But the maximum power is only possible when the load is equivalent of the total internal resistance of combination of the cell, only cell part. So if you only look at the cell part, we know the combination had the resistance in a, correct? Only when this will happen, then you get the, what you get? You get the maximum power received by the load. It's clear. And what is the value of PL max now? Tell me. So I can replace RL by NR. NE by RL we can replace by NR. So this becomes 2NR. If you use from here. So I can replace RL by NR. So it's 2NR into NR. It is clear, guys? And if you rearrange, what will get? N square E square. Sorry, this N. This So what is the answer we are getting here? E square by 4R. Now, if you remember, this was the answer which we got through other method, okay? By using the terminal potential and adding the power of the cell, because what you receive is what you give. So what R will receive is what is the combination giving to the R, right? And we have seen that the rate at which you give the power by the cell, we write as VI. And for discharging circuit, we write as E minus IR. So now here we have NE minus I into NR, because we have NN term into I. So again, it's the same thing. You know the answer is NE I minus I square NR. And then if you solve, you get the same answer. So I'm removing this part. Earlier, we derived the power in context of cell. How much cell can give maximum? What is the maximum power cell can give? Now we are deriving in the context of receiving the power received by the resistance, the load resistance. Okay. And this is the proof that the maximum power given by the cell is the maximum power received by the load. And that is the logical thing, right? You can understand that, yeah, this should be equal. Oh, we have missed one point. N. It's clear? So the maximum power transfer is applicable for any combination of cell, not only for this. Although we have derived for one, you will see that every derivation will have same answer. So let's quickly do this. Parallel group. Okay. So now here we have n cells in parallel. So tell me guys, if all cells are equal, so you can start with mentally two cells. Think of two cells. If both cells are equal, what is the equivalent, guys? Okay, first of all, will there be any current in the circuit? in this loop? Yes or no?
Yes.
Oh, current will be there. Are you sure?
Yeah. Oh, no, terminals are not. The A and B are not.
No, only this loop. In this loop, can we have current?
No, voltages are equal and opposite.
Yeah, so they will cancel out.
Okay.
There is no question of current. And if there is no current, then the terminal potential will be same as. If there is no current, it means R will work nothing, like it's like ineffective here. So what is the equivalent EMF? What is the E equivalent? You can use the Millman's theorem and you will get the answer. You can use common sense, you will get the answer. How much is the answer?
E
Pardon?
by N.
Yeah, E equivalent is how much? What is E equivalent here? For the terminal like this. What is the E equivalent here?
E by 2.
By 2.
Pardon?
E by 2.
E by 2.
E by
Okay, use the formula. Use the formula. Tell me. Leave. Use the Millman's formula. Tell me the answer. What is the formula of E equivalent of for parallel circuit? Anyone getting the answer? Anyone? Please tell me. Come on, guys. You can use the Millman. I'm not stopping you. Use the Millman. Tell me the answer. What is the Millman's formula? Theorem?
sir, so it will be E1 E by R plus E by R whole divided by 1 by R plus 1 by R.
How much is that?
2E by R, no,
E. Very good. So for parallel combination of identical cell, the EMF is same as for each value. Like if you just take one value, that's sufficient because the common sense also will tell you that if you go from A to B, you exactly cross only one cell, isn't it?
Yeah.
The answer must be E only. Na? We look for terminal, and there is no current actually. Because there is no current, so there is no drop or there is no rise. So the E equivalent here is E itself, and the R equivalent will be R by 2 because they are in parallel. Is this clear?
Yes.
If you have n cell, then E equivalent will be still E1. For any number of parallel cell of equal, of identical value, the E equivalent will be E1. But the R equivalent will be how much? For R resistors in parallel, what is R equivalent? Tell me,
E
guys.
by 2.
Pardon? How much you said? For R resistance in parallel, what is the answer? R equivalent. Come
R
on,
by
guys.
N.
R by N. And now this is simple circuit. Now we have one resistor, one EMF, and one resistor. And therefore, the current we can find. What is current here? Current is
E
how
by,
much?
E by
E by.
RL plus R by N.
You can again at PL equals to I square RL. Now this is the in general P, but for P max you can add directly. for PL max, connect directly. What do you connect? For PL max, as per the maximum power transfer theorem, the load must be equal to
N times the resistance.
the net internal resistance of the combination. That's it. Okay. So in that case, the PL max will be how much? Just check it out. E by RL plus RL by L whole square into R. So how much we are getting? It's N E by 2R whole square R by L. What is the answer? You can check, the answer is same, right? Do you realize this?
Yes.
And remember, we are finding the maximum power. This is the formula for maximum power, not for the power in general. In general, we have this formula. We have to solve in general like this. So after the series and parallel, so you can see the drawback of parallel. In parallel, we don't derive bigger voltage. We only get the voltage same as single cell. So if you combine everything in parallel, it's really bad. If you combine everything in series, it is again bad. So now we go for something called mixed group. Mixed grouping of cell. So definitely it will be an array of cell. 1, 2, dot, 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 dot. The nth. E, R, E, R, E, R. 1. Then we have many more. And this entire combination is going to drive some load. So I hope that by now you have realized what to be done. So what we have here, we have n cells in each row and we have m rows. So we have something called capital N called the total number of cells. Okay. So if you have m rows and if each row will have n cells, what is the value of n, guys? N equals to?
M into N.
M into N.
Where? So you have to express the, well, first of all, tell me for PL max, what is the condition without solving anything? Or if you want, you can answer what is E equivalent, what is R equivalent, and so on. Tell me, what is E equivalent, guys? So you can reduce each part separately and think about it. Think of reducing each row first. If you reduce each row, what will you get? What is the E equivalent for the each row? You know the answer. We have done this as the first question. For each row, what is E equivalent? For one row, what is the E equivalent, guys? Am I audible?
NE.
NE. And then we have any in parallel. So in parallel, what we know that the answer of 1 is same for the entire. Yes or no?
Yeah.
Do you realize this, everyone?
Yes.
Yeah.
So what is E equivalent now? Tell me what is E equivalent here?
N.
N. Very good. What is R equivalent here, guys? Think for one row, then think for parallel. You can get the answer. That's very, very important.
N by M R.
Pardon? N by MR. You're seeing this, right?
Yeah.
Correct. So for one row, it is NR, and then we have M row, so it will divide by M. So NR by M. So we are done. So for PL max, the load must be equal to what? The net equivalent resistance of combination. Yes or no?
Yeah. So N by M R.
We are not going to solve this because the MPTT clearly says that the power supplied through the load will be maximum when the load resistance is equivalent of the net internal resistance of combination. Later on in the BTech first semester, you will come to know something called the Thevenin's theorem, which is exactly the precise definition of what we are writing here. So what is Thevenin? How to think about it? I'll also teach you that part. But the word is very dangerous, so you may get intimidated with the word. But the usage is very simple. I'll tell you how to use the Thevenin's theorem. So there are two circuit theorems which are very famous. One is called Thevenin, another is called Norton. Thevenin having uses in JEE, so we should learn. It solves a challenging problem in one line. I mean, these are theorems, and the beauty of theorem is if you remember theorems, you can answer a lot of questions. So if you go back to your class 10th or 9th, you had so many theorems in geometry, especially the axioms and the theorems. And we used to prove the various axioms using the theorem. So, it's the other way. So we use axioms to prove the theorem. So using one theorem, we should prove the other theorem. So theorems are the building blocks of mathematics. It's like the well-defined set of rules which you cannot violate. Okay. So if the sum of the angle on a straight line is 180, that's always fixed. And using that, we prove that the angle of a triangle is 180, isn't it? If you remember the proof, do you remember the proof? The sum of angle of a triangle is 180. Why? Anyone can prove? Class 10th, I think. How many of you remember this? How to prove that sum of the angle of a triangle is 180? Raise your hand if you can prove. That comes from the axiom actually. So if you have a straight line, this angle is always 180. So if you have a triangle, you can draw a parallel line to the base. So this angle is A, this is B, so this is B. This is C, this is C. So A plus BC is 1. This is simple proof, right? Anyway. So for maximum power, the RL must equal to NR by M. And again, what is the PL max value? What is PL max? So by the way, what is the IL value here? If I want to write IL, what should I write here? IL equals to E equivalent upon net resistance, which is
RL plus.
RL plus NR.
very good. And then you can write PL equals to I square R. And then to maximize, we know the MPT50. You can write to use MPT50. And we are done. We are done. So the PL max will be again, if you solve NE by NR by M 2 times, because it's the same thing, whole square into RL, which is NR by M. What we get is very interesting. We will get M N E square by 4R, and Mn itself we called N. So now you can see even this answer is similar to the previous answer. All answers are same. N square by 4R. This is like a universal truth. You must remember. If something is coming again and again, it means it is something which you must remember. So these kind of derivations or basic answers are something part of your theory itself. So We're not supposed to go back to derivation. You should know all these answers and then solve the bigger question. Okay. Now, there is a reverse question. So question is, let n be the total number of cells. RL be the load. And EMF of each cell is E, and internal resistance smaller. Find the number of rows and find the number of, you can say number of M and N. That's just shortcut. In order to derive maximum power to the load. What is given here? RL is given to you. Small r is given to you. Capital N is given to you. You are supposed to find M and N to get the maximum power. Just a reverse problem. So this question is in SQL also. This question is in error also. So there are two questions in the. Don't tell me the answer. Take 3 to 4 minutes. It's very easy. Tell me the answer. It is just formula. You have to manipulate the formula. Get the answer. Go ahead. Got the answer? So whatever be the number of rows and columns, the n will be equal to n, the first question. And we know that for maximum power, you guys are not able to realize what you are doing, right? So given these two questions, can you find n and m? Okay, at least. Let's say n is this and RL is this. Can you find the n and m from here? So 1 into 2. So multiply n RL equals to m n into n r by n. N comes out to be n RL by r root and m will be just reverse. It's clear?
Yes, sir.
So you all got the answer?
Sir, I go. Yeah.
Very good. So this is all from the cell department. So we are done with the cell. Now we can move to the next concept. So the just okay. So now let's go towards something new. So we are going to learn something called RC circuits. So RC circuit you will face in two chapter, one here, and again you will face in the alternating current chapter, AC chapter. The difference is here the driving force will be a constant voltage source, that's called the DC source. There it will be AC source. That's the only difference. And therefore, the way to analyze RC circuit here and there will be quite different. There we use the phasor concept, and here we use the basic KCL KVL, the way we have done so far. So what we were going to analyze is called DC, transient state analysis. Now, what is the purpose of RC circuit? Let me talk about something called RC circuit before we come to the theory again. So, the entire world right now, that means when I'm talking to you, the device which is making everything possible right now is the RC circuit. So, right from the motherboard and the microchip which is installed inside the motherboard by the company, let's say AMD or Intel. So the chip is nothing but a combination of, it's like series of R and C circuit. And the number of these R circuit just goes to millions. So we have millions of RC circuit, and using RC circuit we create transistors. Using RC we create a flip-flop. Using RC we create resistors, which eventually we call memory. Okay? So what we call memory in a device, which you say GB, a memory is nothing but the RC circuit. Then what is the question is, what exactly is the physical meaning of a memory? So how a device or a machine understands what is memory actually? So every capacitor can store charge, and therefore it can have potential difference. So when the potential difference across a capacitor exceeds certain value, we call it a binary 1, and less than that value we call binary 0. So in your laptop there is a button called F5, which is the refresh button. Okay? So what happens generally when you have the information stored in these infinitely large number of capacitors, with time they tend to lose the charge. A refresh button will restore the charge back to the value so that the information remains intact. So our information is basically the way we understand information is of course in the language which we know, let's say your English, your vernacular language. A machine cannot understand anything more than current and voltage. So deep down every device, whether it's an electronic device or it's an analog device, the entire world is governed with either voltage or current. So let's say if I'm using a microphone, it is doing the same thing. So first of all, my voice is creating a pressure in the air. Okay. This pressure is getting impacted on the microphone. There is a diaphragm actually. And based on the pressure which it is receiving, it is creating equivalent variation of voltage or current. And that current is flowing through the wires, and it is getting converted into a digital format, which is eventually getting transmitted through the Wi-Fi, the nearest router. The router is sending to the nearest service provider. The service provider is taking to the destination, and where you all are receiving the information, again decoded back to the voice through the speaker in the earphone. It's a long process. Okay. And in between, there are lots of mechanical, I mean, you can say electrical and electrodynamic or electromagnetic forms. It is getting converted, and eventually the information is reaching to a distance. So RC circuit is the base of every device. I mean, every electronic device is meaningless without the RC circuit. And what you call particularly a chip, the Intel chip, is nothing but just R and C. But the question is, why a chip will have the limited number of R and C? R and C are physical objects, so they have dimension. If you remember the formula for capacitance, it is epsilon naught A by D. So there's a dimension. If you talk about the resistance, there's a formula rho L by A. Again, there's a dimension. So the finest, if we use the finest laser possible, the monochromatic light which we are trying to achieve as much as possible, the finest laser can make the finest cut, and therefore the smallest dimension that we can cut it, that is the smallest capacitor or RC circuit we can build at. And therefore the number of capacitance or number of RC circuit that we can eventually build on a physical chip is going to be limited because of the dimension. Because laser will also have dimension. So if you use a laser of wavelength some nanometer, so nanometer is putting a dimensional constraint actually. We cannot go to picometer. So in future, if we can go to picometer, then definitely we can increase the number of chip size. But that seems to be difficult as of now. So what we're moving towards is, we are moving towards the multiple processor system. So we are trying to create quad processor, like we have 4 processor working independently, but the architecture is designed in such a way that all can synchronize with each other. So the maximum throughput, the output you are getting is much more, but we are not increasing the dimension of each RC circuit. Rather, we are trying to use multiple processors. So that is the change. Now we have gone from the single chip to multiple chip in a single computer. Okay. So nowadays, if you buy a mobile phone, you have the Qualcomm Snapdragon quad processor. Basically, they are using the parallelism concept in computer architecture. And what they achieve is they use multiple computation in various chip doing independently, but the rule written, the protocol written in such a way that we are believing it's happening at one place, but that's not the truth. It's happening at 4 different places. Anyway, so we're not into the computer science, and definitely that's not our topic of discussion. But what you call chip is basically RC circuit. Now, is it confined to there only? No. Your human body itself is the RC circuit. So your heart is a capacitor. It's a dipole, it's a capacitor, and therefore the human body also having a resistance. We also have the capacitance, and the best thing is every single cell of human body is a spherical capacitor with charge storing capacity. Okay, so it is the charge on each cell. You can imagine the size of the cell. So you can imagine the size of the human body and number of cell. So we have such a tiny charge configuration throughout the body, and through that charge, we get our memory. Okay, so even our memory is based on the charge. So we have synapses, we have dendrites, and we have so many things, and they all fire and all. This all thing is actually some sort of charge exchange. Chemical reaction creates again charge. The entire neuron network is charge processing unit. So we transmit charge. We create charge somewhere, we transmit, and the entire information we store as some sort of charge. So there's something called firing of synapses, and there is a location in the brain called the dendrites, okay, which is the activation point. And again, this is the entire literature which is only dedicated to the idea of neurons and how the brain works. So we do have the brain wave also. Okay. So you are a live RC circuit working in a most complex possible way. Okay. So if chip is so complex, imagine the human body, how complex we are. So the brain is the powerhouse. We call brain is the powerhouse because here the maximum energy is consumed by the brain. And there's a voltage rating of the brain also, that your entire body energy which you produce, maximum power, part of the energy is consumed by the brain. So if you use a lot of thinking, you get tired because you have consumed your energy. Even thinking can make you tired, a lot of thinking. And then there is, of course, excitement and all, which gives you some extra energy. Okay. But that is not natural. I mean, of course, the body is consuming some part of energy and giving you extra energy to the brain. So RC circuit is in our day-to-day life everywhere. So every device which we create is having eventually an RC circuit. R is kind of hidden. R is not in front of us. Okay. So It is a by default. Every medium will offer some resistance. So by default, a medium is a resistor. So there is no need to have the R in the zigzag form everywhere. This is circuit notation. R is the property of every medium. Except the superconductor, every medium will have some R. That is the truth. Some will have more, some will have less, some will have much more. So when you talk about insulator, it is having infinite resistance. If you talk about the conductor, it's having very less resistance. If you talk about superconductor, it's almost zero resistance. And then we add some impurity to create a desirable resistance. Okay, so we use carbon, we add carbon to the metal, or we derive the carbon resistance. So the resistance is the concept, and it is meant for every medium, and therefore it is everywhere. So you can say resistance is everywhere. Capacitance is a process by which you store the charge. So again, that is everywhere. So whether it is a living thing or non-living thing, the idea of information, the idea of communication, the idea of memory, all are through the charge process. And therefore, we need some way to store charge because that is representing an information, a piece of information. So one charge is actually containing some information. And so by varying the charge, we can create a complex information. And through complex information, we create the idea of, you can say, uh, speech, idea of knowledge, and idea of significance. So what we're going to analyze here, that if we have a capacitor and if we have a cell, okay, we want to see our end goal is to charge the capacitor, but we cannot, take charge physically by hand and put on the plate. That's not possible. It's not like we are having a brush which you dip in a paint tub and you just paint the wall. That's not possible. The process of giving charge to a plate of capacitor is a difficult task. I mean, it cannot be done manually. So we take the help of a cell. We take the help of connecting wires, and then we put the plate in between, and then the charge transfer will take place. Now, the connecting wires will offer some resistance. So whether you assume or not, there is always some hidden resistance, which is part of circuit. When you put R explicitly, you talk about the large resistance. When you don't put it explicitly, you talk about the almost zero resistance, if you talk about pure conductors. So whether I say C circuit or whether I say RC circuit, both are equivalent technically. Because R is always there. We cannot avoid R in most of the cases. So the question is, what is the role of R? The answer is, it helps in controlling the rate of current flow. Because if R tends to zero, then for a given potential, the current will become infinite. Now, such current is good or bad? The answer is, if you are creating a device for some purpose, a large current can damage the circuit. The large current can damage the device itself. It can create the ignition. So it's very dangerous. So R is like a controlling factor. So our goal is to charge the capacitor with some control in our hand, and the control is given by the R. And that is the reason of birth of the RC circuit. Okay. So you have the control. So if I write control, the R is the control part. Our goal is what? Information. What is information? It is potential. And how to get it? By putting charge on capacitor. Okay. So in RC circuit, we talk about two things. First is called charging process. Okay. And again, we also have discharging process. Sometimes we need to delete the memory. Okay. Remove the information. That is like discharging process. Okay. So our brain is capable of charging and discharging automatically. Okay. And the best part of the brain is it is always having this ability to discharge, because that will remove the unwanted memory. We don't want to store every information which we receive on a day-to-day basis. It will just bring a burden to the processor. So forgetting is a good habit. It's good to forget things. If you talk about the youngster point of view, it's a bad habit. Okay, but forgetting is natural and it's good. Nothing to worry about. Unless you forget everything. about your name, about who you are. That's dangerous. So we'll start with the first process called charging of capacitor. So if we have R and C, and we have some source, because charging cannot occur on its own, we need to bring some source, some voltage source. We also put a switch, and let's say that there is no information as of now, so it means there is no charge actually. You can think this way. So we have a neutral, I mean, you can say chargeless capacitor in the very beginning, no charge at all. We have a cell, and R is just for the controlling factor. So the role of R is to delay the process of charging, and we are okay with the delay. I mean, it should not be very quick and dangerous. Rather, it's slow and safe. So the rule is simple. This is the circuit, RC circuit. The name is obvious. Why we call RC? Because we have R and we have C. The cell will do the charging process the moment you switch on the circuit. So if you switch on, so we call switching on as, mathematically there is a name for it, switch on. So switch on we write as T tends to 0 plus. Just this means just after switching the circuit, switching on the circuit. Right now, what is the charge on capacitor? Tell me, guys. What is the charge on the plate of capacitor? Just after switching on, what is the charge here? 0 and 0. Yes or no?
Yes.
Yes.
We know from capacitance chapter that the potential across the capacitor is Q by C. Yes or no?
Yes.
At since VC is Q by C, at T tends to 0 plus, the VC becomes 0. Yes or no?
Yes.
Because without charge, it will not create difference. No? And if there is no potential difference across a capacitor, then what is the role of capacitor here? It will act as a, if there is no potential
To
difference,
act as a conductor.
yeah, it will act as a
Conducting wire.
conductor. So it will be, it is now short circuiting the terminal across it. So it will act as a conducting wire. You can replace just like a wire, and then think of the remaining circuit. So at T tends to 0, at T tends to 0 plus, when capacitor is uncharged, at T tends to 0 plus, when capacitor is uncharged, capacitor will act as short circuit, which means you can replace by a wire. So the entire circuit will look like R and E, isn't it? Because we are replacing the C by a wire. So what is the current right now? Current right now is how much? Come on, what is current right now? In this circuit, what is the current, guys? Tell me.
Sir, E by R.
So much time to answer this question. That's not good. So the current in the circuit is E by R because it's a simply R circuit. Now, right now, it is not RC, it's a R circuit, and therefore current will be E by R. And you can see clearly, if you make R tends to 0, it is dangerous.
Yeah. Infinite.
Infinite, which is not desirable. We have to keep the safety in check because we use in a real world application. Safety is very, very important. R is, you can say, necessary evil. Because R will dissipate the energy, but it will also control the energy. So somewhere it's good, no? So control is important than the value. Okay, so I notice E by R. R is controlling the current. I hope this is clear. Now, this is the
Yes.
moment at t equals 0. What will happen after that? After that, current will start. What is the meaning of current? Current will means
Flow.
charge will go from the cell towards the plate. So after some time, the charge will start depositing on the plate. Yes or no?
Yeah.
So can we draw something like this? And now I can say some charge will get deposited here. Because current is going to this plate, so this plate will acquire the positive charge. Yes or no? So this plate
Yeah.
will acquire the negative charge.
Negative. Yeah.
So at any random instant t, at t equals to t, what will happen?
Sir, capacitor will be fully charged.
No, no. At t equals to t, it will not be full charge. It will have some charge.
Okay. Some.
Some charge. Now, a capacitor with charge will oppose the incoming current or support the incoming current. Tell me.
Sir, it will oppose.
Yeah, because the positive charge will try to oppose the incoming charge. Yes, yes or no?
Yeah.
And if it will oppose, so current will decrease or increase. So capacitor will also act as a cell. No? You can replace this with like a cell like this
Yeah.
VC. So now there are like two virtual cell E and VC, right?
Mm.
So current at any instant will be how much? The net potential upon R.
By
Yes
R.
or no?
Yeah.
Do you realize this? Maybe. May not.
Yes, sir.
So we can add VC equals to Q by C if you remember.
Yeah.
So this is called at any time t. Now, how long the charging will take place? That's the question. Will it happen forever or will it stop after some time? What do you think? The charging will keep on happening or will it
No, sir, it
eventually
will
stop?
stop. It will stop.
Because the Q will, if I will continue, the charge on the plate will grow. Yes or no?
Yeah.
But if charge will grow, then Q by C will grow. Yes or no?
Yeah, directly proportional.
And if Q by C will grow, then eventually you're going to balance the. If Q by C will grow, then eventually you're going to balance
Voltage.
the EMF E of the cell.
Yeah. E. Voltage. Yeah.
So some one fine day, the Q by C will be equals to E. And when that will happen, then current will be how much?
Zero.
Now, what does it mean? That is called the steady state or equilibrium state of circuit. The charging has been completed, and once the charging will complete, that's called the meaning of completion. See, capacitor can take much more charge than what it is taking right now. I'm saying a cell cannot give infinitely charge. A cell with its power, its force, can only give up to certain value of charge. If I bring a stronger cell, let's say if I replace E by 2E, what will happen again? Current will still continue towards the plate. Yes or no? So let's say E and the charge, it's Q by C now are equal. And now current is 0. What I'm saying is, if I replace this E, this cell by a bigger cell, more EMF, 2E, And if I connect, what will happen? Current will re-establish, yes or no?
But capacitor is charged.
No, but capacitor cannot oppose much more. No? Capacitor
Yeah,
can only oppose, see, capacitor is only able to oppose up to E.
yeah,
You charge with E, na?
yeah. So for 2 it will more.
So for 2E, it requires more charge, na? To oppose and stop.
Yes, yes,
Are you getting it?
yes.
If you bring
Get.
another cell, then charge will again start flowing in the circuit. If it is more than the previous cell, previous EMF, if the EMF of the new cell is more than the EMF of the old cell, it will further do the charging. If the EMF of the new cell is less than the charge on the capacitor, if PYC exceeds the new EMF, it will discharge till it acquires charge as per the new cell. So the idea
Yeah.
is capacitor will not decide the charge. It is the cell which decides how much it is capable of putting there, not the capacitor. Capacitor is like a plate. It can store any amount of charge, but it is the cell which will decide how much. So capacitor will have no control. It is the cell which will bring the limitation. So every cell will have its own limitation. Understood? It is clear what I'm saying?
Yes,
So the
Yeah.
final charge on the plate of capacitor will be decided by the cell, not by the capacitor. See, capacitor is just a storage device. It will store what it will give. So what we see that in this case, okay, let's look at this case. So when t tends to infinity, which we call steady state, or it is also called the equilibrium state. What will happen? The current in the circuit will be zero. Why? Because current means the plate will keep on acquiring the charge. If current is zero, it means no extra charge can come. Why? Because the repulsion of the capacitor and the cell EMF, you can think EMF as a force, just like Newton's law of motion. So basically, this RC circuit is like a spring attached to, no, not attached to, it is a spring which is pulled with force. So up to what extension it will stop? When F equals to Kx, so at equilibrium, F will be equals to Kx, X equals to, so just like in mechanics, we write spring force equals to Kx and we can say X equals to F by K. In RC circuit, you can think F as EMF, K as inverse of capacitance, and X as charge. So EMF is like a force, the push, how much charge you can hold on the plate. Okay, it's like you're pushing the charge, you're not letting it come back. So you are powerful enough to hold those charges on the plate. The moment you remove yourself, the moment cell is removed, all charge will go back to the original position and the capacitor will become uncharged. And even you can correlate this always. Anyway. So T tends to infinity is called a steady state, and in the steady state, I is zero. If I is zero, what is the rule of R then? How much is the drop in potential across R in steady state condition? The voltage across resistance will be how much, guys?
0.
So R will act as short circuit.
Yeah.
Yes or no? And therefore it
Yeah.
is just like one capacitor and one cell. That's it. And we call this charge as the final charge, U naught. And because there is no current, what you can say? If you write the KVL, the way you have learned, move like this, plus E, minus control C, this must be 0. Yes or no?
Yeah. Yes.
So you notice how much? So a cell of EMF E, when connected across a capacitor of capacitance C, will only give the charge C. So as you vary the E, the charge will change. Yes or no?
Yeah.
So more the E, more the charge. Are simple. Less the E, less the charge. No E, no charge. Simple. So these are called the two extreme cases. When we have a capacitor in the steady state, it will never allow the current to flow. Now these two ideas is very, very important to solve question in RC circuit. I'll take 5-6 more minutes, then I'll leave for your next lecture. So if I give you a circuit like this, R, Q, R, E, R, C. I must give switch. In the very beginning, the capacitor is uncharged. We have a switch. Question is, find the final charge on plate of capacitor in steady state condition. Questions clear? No, right now you have no idea what is going to happen, but I can see that, okay, if current will flow like this, will come here, will get divided here, and therefore some charge will deposit here. So okay, the charge on the plate we can understand. It should be something like this, isn't it?
Yeah.
So once you switch on, and after if you release it for, if you leave it for long time, the capacitor will acquire sufficient charge based on the potential difference across it. But once it will get fully charged, it will stop the flow of charge, right? And we can also understand that, okay, eventually the charge will stop, isn't it? Eventually the charge must stop, yes or no? Eventually the charge through the capacitor, the current through the capacitor will stop, yes or no?
Yes.
So in steady state, nothing can go through the path in which capacitor is present. Okay.
Yeah.
So the path in which C will be present, no current can go through that path, because that is called steady state condition. If we have achieved the steady state, then capacitor will not allow any current to flow. Then what we do is we look for the alternative path. Is it possible to have a loop with current, ignoring the capacitor? So let's throw out the branch which contains the capacitor. So we can clearly see, I hope you can also see, this path is the branch, this branch is the containing capacitor, right?
Yes or no? You can see.
Yeah.
And
Yeah.
nothing can flow from here.
Yeah, nothing.
So this entire branch is like dead now.
Disconnected.
So we can ignore. We can cut from here. We can cut from here. Cut from here. Cut from here, and remove it and mentally remove. So this is as good as. So that part is gone mentally, and we can just draw the part which is or which could be still active. So luckily, what we see here, even if I throw the branch which contains capacitor, I have a branch, I have a loop with only cell and resistor. So current will be there. Why? Because it's a closed path. So what will be current here? Even in the steady state, current through the cell will be there. There is no current through the capacitor. This current is zero. But it doesn't mean that current will be zero for everywhere. So now we have a path without capacitor. Even if I throw it, I still have a closed path. Do you realize this? So what will be the current here, guys? Tell me. I equals to
So 2.
what? How much?
5. 5 E by 5.
E by 5R?
Yeah.
Right? Yes or no?
Yes.
Now the question is, what is the charge stored on the capacitor? How to get that charge? To find the charge on any capacitor, the rule is find the potential difference across the terminal of capacitor, because the charge is always C into potential difference. Now, the capacitor is in a branch, let's name it A and B. Because there is no current in that branch, so R is null and void, so there is no role of R. So can we say the potential across A and B is the potential across capacitor? Yes or no? This is very, very important. Can we say potential across capacitor is same as potential across A and B?
Yeah. Sir, there is resistor also.
So what?
No, it is same. Sorry.
Because there is no current. No? In the
Yes.
path of in the rightmost path, okay, you need to realize a lot. This path having no current, but this path is
Yeah.
having current.
Yes.
Now the beauty of circuit is that if you know the 2 points, now no matter which path you choose, the potential remains same. I do not know the charge on the capacitors, so I cannot walk on the path from the right side, but I can go from A to B from the alternative path.
Yeah.
See, I have to find the potential difference between A and B, so I need to choose a path in which I know the values. So I can go from A to B and in which everything is known to me. I know I know R, so I can get A to B. So can you guys walk the path from A to B? So VA minus I into 2R minus I into R equals to VB, yes or no? So
Yes.
VA minus VB is how much, guys?
Mhm.
3IR, and IR is E by 5, so this is 3 E by 5, right?
Yeah.
So charge on capacitor is basically the capacitance into the
Mhm.
potential difference which we got.
Yeah.
The answer is 3 by 5 C. Do you guys realize this?
Yes.
Everyone? Is this question clear? This is very important for all of you.
Yes, sir.
So just before we wrap up, let's do one last question. Easy one, but conceptual one. So we have a resistor R with capacitor C. We have resistor 2R with nothing. We have a cell. Find the current through cell at t tends to 0 plus d. Tell me guys, what is the answer? If you have understood the concept, you can tell us. So at t tends to 0 plus, what will happen? An uncharged capacitor will act as short circuit, right?
Yes.
So this circuit can be reduced.
Yeah.
So what is the R equivalent of the reduced part?
2 by 3.
2R by 3.
2R by 3.
Correct. What is the current through the cell?
E by no. So 3E by 2 R.
E by how much you said?
3E by 2 R.
Correct. Very good. And for B part, capacitor path, the path in which C is present, no current will flow, right?
No current. Yeah.
So still we have one path left.
Yeah. So E by 2 R.
So those who have understood this concept, raise your hand. Two guys. Archit has not understood. Archit, Garv, Kanu, Manav, Nishi, please raise your hand. If you all have understood, raise your hand. Very good. Manav has not understood. No problem. Manav, are you there? Hello, Manav, are you there? So last. Find the charge stored on each capacitor in steady state. Find charge on each capacitor in steady state. So I'll give you just 5 minutes to solve, then I'll solve, and then you can leave. So you all got the answer? If not, then you will get this as well. So you all will send me the answer. Okay? So sending the answer in the next lecture, we'll discuss more about R C Ckt. This is just the beginning. We haven't actually entered the R C Ckt. It's just the extreme end. The infinity and zero are two cases in which we deal with a large variety of questions. Then we have something in between, which is difficult. So we'll see that in the next lecture. Till then, you can wait for some more time. Then we get a large number of numbers. Bye guys. Take care.
Bye, sir. Thank you.
Thank you, sir.